Hi, in this short video we're going to look at iteration exam style questions. This is a fairly new topic in terms of what's in the GCSEs, but it seems to come up every year in this kind of predictable form. So these questions always tend to be sort of a three-part question, and those three parts always tend to be the same. First part is showing that a solution exists between two values. All you need to do here is just plug each value in and show there's a change of sign. So when x equals 0, we're going to work out what x cubed plus 5x minus 4 equals. For that, you just plug it into calculator. You do that, it just comes out at minus 4. We then do the exact same thing for x equals 1. Plug it in here, and that's going to give you 2. You will always find this for each of these questions that there's going to be a change of sign. And it's going to say some sentence along the lines of, there's a change of sign, so there's a solution between 0 and 1. In terms of marks for exams, you basically get 1 mark for your working out and 1 mark for saying that because of the change of sign, then there must be a solution. So that's the part A. Again, that's pretty reliably the same for every style of question. Part B always tends to be a rearranging part. So you want to rearrange this to give you this. Now for all these questions, it's so much easier to start from the finish and basically work backwards. If this was like an exam, what I was just doing is actually writing the answer like at the bottom of the page, and then just work backwards from that and basically work up the page so it looks like you've gone the right way around. So here, basically just do normal equation-y mathsy things. So what I mean is, whenever I'm teaching it, whenever you see a fraction, your first step is going to be to want to get rid of that fraction. So I'm going to times both sides by x squared plus 5. Next, the obvious mathsy thing to do is just to expand that bracket out, which gives me x cubed plus 5x equals 4. And then for all these equations, we can see that pretty much without fail, they're all equal to 0. So then we just take the plus 4 across, which makes it a minus 4. And again, if this was a proper exam, I'd make it as clear as possible. So then I'd basically include these same steps. So it looks like I worked it out the right way around. Okay, and again, for every single question, it always tends to be those three parts question. That's always the middle part as a rearranging part. Lastly, for part C of an iteration, so the form we rearranged it into, we now turn into an iteration formula, and we need to use this one twice. So again, make sure you keep account how many times you're asked to use it. So to do this is all calculator work. Our first value is 0, so you press 0 equals to log that into our calculator. Then we're just going to copy the right hand side here. So fraction 4, rather than xn, I'm going to write answer. It has to be answer squared because it's xn squared. That's my iteration formula, and we need to do it twice. So once and twice. So that gives me 0.709. Again, if you're being more cautious, it's also worthwhile writing down the x1, I think it was 0.8. And then x2 is that value down there. But you don't need to do that, but sometimes it's worth doing it to make sure you're not sort of making a silly mistake and this way you still at the method mark. Okay, let's do that same idea again. So again, all questions basically follow these same steps. So when you've done one, it gets so much easier doing the rest. This one is a bit of a different for the first part, by the fact that this equals 1 rather than equaling 0. Probably the easiest thing to do is just rearrange this so it does equal 0, and then treat it like the previous questions. So these two are perfectly equivalent. So if we can show that this has a solution at 0, it's the same as saying that this has a solution at 1. So rearrange it, then just as before, I'm going to plug in 0 and 1. And I'm going to work out what this is going to give me. So you plug in x equals 0 to this, you're going to get minus 1 coming out. You plug in 1 into this, and you're going to get 4 coming out. And then you'd write a little sentence. Because there's a change of sign, then there is a solution between 0 and 1. Okay, that was our first part. Our next part for this question again is the rearranging part of the question. Occasionally you have a fraction thing to rearrange it into. again, for my first step, again, I'm working from the answer backwards. My first step is going to be to have that as just one big fraction. So here's quite easy because it's just already got a common denominator of 4, but if not, I would find a common denominator. And then I'm going to rearrange it to look like this. And then just do normal mathsy things. So the key rule is get rid of any fractions. So 4x equals 1 minus x cubed. And I'm going to make it all equal to 0. So I bring everything across the left-hand side, which flips the sign for the x cubed and for the 1. So now it's x cubed plus 4x minus 1 equals 0. That's the same as that. Possibly should have left a 1 across. Make it look at the exact same. And then we're done. If it was an exam, I'd basically just rearrange those working lines to sort of be fairly cheeky about it, so just make it as clear as possible that you know what to do. I'm going to take it straight to there. Okay, and again, part C, we have another iteration part. So let's go for that again really quickly. First things first, you log in 0 as your answer. We're then going to copy down this right-hand side into my calculator. Everywhere I see answer, I'm going to write xn instead. So here's the answer cubed, because it's xn cubed, over 4, and we're using it twice. So once, twice, that's my answer, 0.246 to 3 decimal places. Okay, just one more. So one has a slight different part for there's an actual part D in this question. So I won't go through part A, but that's the exact same idea. You plug in 0, you plug in 1, there's a change of sign. Part B we'll go through quickly. Again, we start from the end, we do normal mathsy things. We want to get rid of that fraction. So we times up by x squared plus 7. We then expand out that bracket. And then if I take the 5 across, I'm done. It's now the exact same as this. Okay, then again we have the iteration part. Again, that should be feeling more straightforward now. First step, we log in our first value, which in this case is this 1 here, into my calculator. I'm then going to type the right hand side into my calculator. And I do iteration 3 times here, so press equals 3 times. So once, twice, thrice. That gives me 0.67. We'll say 0.44. Okay, and again, if you want to be more sure or sort of more cautious to make sure you're getting full marks here, you can also write down x1 and x2. But I think you're required to. If you have the right answer, you will get all 3 marks. Okay, here's the part D, and this is related to a few more questions. Occasionally it will say, you've worked out this number, fantastic, but what does this number represent? The whole point of basically all these steps is to try and solve this equation here. The equation right at the start, the x cubed plus 7x minus 5. So when you press equals to get this answer, you are finding an estimate for the solution. And if I go back to here, the more times I press equals, the more accurate that solution will get. Okay, so the solution we had was this one here. We're going to use that in a second. So now in part D, it asks us to comment on the accuracy of our solution. So we've got our solution here, and that's still stored in our calculator. What I'm going to do, I'm going to plug that, let me just zoom in a bit, into this equation. I'm going to plug that into this equation here. So for that, I'm just going to copy the equation down. Of course, anywhere I see x, I'm just going to write answer instead. So answer cubed plus 7 times answer minus 5. I'm going to see what that equals. That gives me this. So I would say, substituting in my answer to part C, I get, let's have this not in a standard form, so it's 10 to the minus 3 here. That means there's 3 zeros before it, so it's going to be 0.00 and then that string of numbers, and that was 549. So that's going to be one part of the answer. We found out how accurate I am. We sort of need to comment on the accuracy, which is kind of a weird thing to do. You basically want to say how close you are to the correct solution. Okay? So to do this, I would just basically quantify what I know about this. It's not an obvious thing to answer. You can say, so my error is very small, which is only that number itself, because it should have been 0. So therefore it's going to be a good estimate to the solution. Okay, you basically just want something that you know what you've worked out, and you also know what it should be. I'm really close to 0. You'd also say I'm correct to 2 significant figures in terms of how accurate this is. Okay, I hope that helped. Good luck, and thanks for listening.